Hi everyone, today we will discuss about the heat transfer. What is heat transfer? That basic definition of heat transfer. The topic name will be there, heat transfer. See here, what is heat transfer? Heat you know very well, heat is a one form of energy, heat is a one form of energy which heat can neither be created or neither be destroyed, like similar to energy only, but one form is converted to another form. Sometime it will be water, sometime it will be vapor, or sometime it will be gas. So, one form will be converted to another, another form will be converted to another. So, this one is known as a heat, okay na? Transfer. Transfer means always what will happen from, suppose one hot body is there, if you consider some hot body, from hot body and some cool body is there. Here the body temperature is equal to, let us assume this one is the body A and this one is the body B. We are not considering the atmospheric temperature, surrounding temperature we are not taking that, only we are considering this two bodies present. For this body the temperature is equal to how much? 40 degrees is there. For this body the temperature is equal to how much? 15 degrees is there. For the first body the temperature is equal to how much? 40 degree. For second body the temperature is equal to how much? 15 degree. After some time, if you observe that this is body 1 and this one is the body 2, this one you consider as a body 1, this one you consider as a body 2. After some time what will happen here? You will observe the temperature of this one will be 25 and the temperature of this one is also somewhat 25, okay na, some 25 or somewhat 30 also, 25, let us assume 25, it should be equal. Heat, when till what time it will be transferred take place, means when both the body temperature will become equal, till that it will be transferred. So, as you can see that previously how much temperature was there? 40 degree for body A, and after that how here for body B what temperature is there? 15 degree. After some time if you observe that, so here the temperature is decreasing and here the temperature is increasing, here the temperature is decreasing, here the temperature is increasing. So, automatically no need of any external agent, automatically heat will be transferred from higher body to lower body without aid of any external agent, no need to add any external agent in this. So, automatically the heat transfer will be take place. So, this one is known as heat transfer. So, various form of heat transfers will be there, various modes of heat transfer will be there, classification of heat transfer will be there. So, in that we have to discuss that one. So, here body A will be there and this one is the body B will be there. For body A temperature is equal to how much? 40 degree. For body B temperature is equal to 15 degree. After some time if you observe that body A temperature will decreasing and body B temperature, till both the temperature will become equal. For body A temperature and body B temperature will become equal, till that time heat transfer will be taking place, So, this one is known as the heat transfer. Important topic is there, you have to remember what is heat transfer, okay na? It is a form of energy will transfer from higher body to lower body, it is a form of energy will transfer from higher body to lower body, it is a form of energy will transfer from higher body to lower body. From lower body to higher body also you can transfer the heat, but you need any external agent. Without any external agent you can't transfer the heat from lower body to higher body. Without any external agent you can't transfer the heat from lower body to higher body. So, this one is known as the heat transfer. Simple definition, in own definition, if you want to say that what is heat transfer? Heat is a form of energy we transfer from higher body to lower body. This one is the higher body and this one is the lower body. So, heat can be transferred from higher body to lower body without aid of any external agent. You can transfer the heat from lower body to higher body also, lower body to higher body by the aid of external agent, Next one important thing is the modes of heat transfer. How many modes of heat transfer will be there? Normally heat transfer can be classified into three types of modes. So, here I will write MODES, modes of heat transfer, What is that? Modes of heat transfer. This is the important one. In short also it will come. First one will be there, conduction. First one, what we call this one as the conduction. Second one is conduction. Next one is called as the convection. Next one is the convection. And third one is the radiation. REDIATION. Radiation. third one is the radiation, first one is the conduction, second one is the convection, and third one is the radiation, radiation. I will write properly here. See here, conduction, convection and radiation, conduction, convection and radiation. As you can see here, this one is the conduction and this one is the convection and this one is the radiation. What is conduction means? Conduction means solid to solid, if heat transfer taking place, that one is known as the conduction. If solid to solid heat transfer is taking place, that one is known as the conduction. Suppose this is my body A, this one is my body A and this one is my body B, this one is my body A and this one my body B. If I couple this body, if I transfer like this, see, so automatically heat transfer will take place. Solid to solid, if heat transfer is taking place between two body, if solid to solid heat transfer is taking place between two bodies, that one is known as the conduction, that one is known as the conduction. Next one is the convection. Convection means solid to liquid, liquid to liquid, solid to liquid or liquid to liquid. Suppose this one is one body is there, okay, now one body is there. From here, if you are supplying the heat, from here you are supplying the heat, okay, this is body A, from here you are supplying the heat. So this type of heat transfer, it is known as the convection. This type of heat transfer, it is known as the convection. If solid to solid heat transfer is taking place, that one is known as the conduction. Solid to solid, if heat transfer is taking place, so that one is known as the conduction. If solid to liquid, if solid to liquid or liquid to liquid heat transfer is taking place, that one is known as the convection, that one is known as the convection. See, next one is the radiation. Radiation means, suppose something is there here in a jug, something is there. Suppose the heat transfer is taking place from this side. So this term as known as the radiation. This term is known as the radiation. This one is known as the conduction and this one is known as the convection and the last one is known as the radiation. These are the three types of modes of heat transfer. Normally this one I will call as the modes of the heat transfer. Once again I will tell you how many types of modes of heat transfer. First one is the conduction, second one is the convection, third one is the radiation. Conduction, convection and radiation. Conduction means if solid to solid body, if heat transfer is taking place, solid to solid body, if heat transfer is taking place, that one is known as the conduction. As I already told you, here temperature is equal to some 40 degree and here temperature is equal to somewhat 15 degree. Here how much temperature is equal to 40 degree and here how much temperature is equal to there 15 degree. If you couple these two, if you see, if you keep both the body as side by side, if you keep both the bodies as side by side, this body is also solid and this body is also solid. If solid to solid, if you keep beside, so after some time if you observe that this temperature of A will be decreased and temperature of B will be increased till both the temperature as same, till both the temperature attain the same temperature, till both the bodies attain the same temperature, it will call as the conduction. That one is called as the conduction. See, so in hot water, suppose hot water is there. In hot water, if you are mixing the cool water, in hot water, if you are mixing the cool water, so that type is known as the convection. That type is known as the convection. See, other than conduction, if you want to define the definition of radiation, what you can say, other than conduction and convection, it is known as the radiation. Other than conduction and convection, it is known as the radiation. So modes of heat transfer: conduction, convection, radiation. Conduction, convection, radiation. You have to remember, solid to solid, if heat transfer taking place, that one is known as the conduction. Solid to liquid or liquid to liquid heat transfer is taking place, that one come under the convection. And other than conduction and convection, if any other type of heat transfer is taking place other than conduction or convection, if other type of heat transfer is taking place, that one come under the radiation. So these are the three modes of heat transfer. These are the three modes of heat transfer. As you can see here in this diagram, I took the one pan I took. In that pan, from here I am supplying the heat. In this pan I am supplying the heat from here, and inside what is there? Water is present. Inside what is present here? Water is present. Inside what is present in that pan? What is present? Water is there. From here I am supplying the heat. From here what I am supplying? Heat I am supplying. Here what I am supplying? From here I am supplying the heat. From here what I am doing? I am supplying the heat. So whatever the water is there inside the pan, whatever the water is there inside the pan, after some time it will be, after its saturation. What is the saturation of water temperature? 100 degree. After 100 degree what will happen? The temperature of a water will be changed. After 100 degree the phase of a water will be changed. The previously phase is equal to what? Water is there. After some time it will become vapor. Here previously temperature is equal to what is present here? Water is present. In that what is present here? Water is there. If you apply the heat continuously, the temperature, saturation temperature of water is equal to how much? Is equal to 100 degree. After 100 degree it will change its phase from liquid to vapor. From liquid to vapor. This one is known as the vapor. So after 100 degree the water temperature will be changed, liquid to vapor. So this one is the vapor, and here handle is there. What is there here? Handle was there. This one is equal to handle is there. This one is equal to handle is there. Okay, now in this what is there? Handle will be there. Now what will happen? What is conduction? So we'll understand the clear concept of what is conduction, what is convection, and what is radiation. What is conduction, what is convection, and what is radiation. As you can see here, if you supply the heat, automatically the water temperature will increase. Automatically, first it will transfer heat to this surface body. First it will transfer heat to this surface. After that water will be heated. After that water again it will converted into steam. That water again it will converted into vapor or steam. Vapor or steam. Vapor or steam also you can say. Okay, na, vapor, or otherwise we will say as a vapor only. After that it will converted into vapor. So from here you are applying the heat, and here what will be present? Water. So that heat will transfer to the water. After saturation temperature of water, that water is converted into vapor. This total can will also heat. So after heating this can, automatically the boundaries of this can, automatically this handle will also increase. Suppose it is made up of iron or some other material, automatically the temperature of a handle will also increase. In your spoon, in your kitchen, if you keep the spoon inside your can, and after that if you started, so automatically here also temperature will also increase. So if this temperature will be increased, so automatically this temperature will also increase. This is the solid body, and this one is also the solid body. This one is the solid body, and this one is also solid body. This is the solid body 1, and this one is the solid body 2. I mean, difference are there, but there are couple, there are connected. So this type of heat transfer from here to here, first coming from here, then it is transferring here. This is one type of body, and this one is the another type of body. This is the one body, and this one is the here is screw and nut arrangement will be there, easily you can open. So two different bodies are there, but both the bodies are solid. This body is also solid, and this body is also solid. As you can see, this body is also solid, and this body is also solid. When the two solid bodies will transfer the heat, when the two solid bodies will transfer the heat, that type of heat transfer, it is known as convection. That type of heat transfer, it is known as conduction. This type of heat transfer, it is known as conduction. When two solid bodies are transferring heat, when two solid bodies are transferring heat, so this type of body, this type of heat transfer, it is known as the conduction. This type of heat transfer, it is known as the conduction. Now let's go for the convection. As I told you the definition of convection, what is convection? As I told you the definition of a convection, if solid to solid or solid to liquid or liquid to liquid, means solid to liquid or liquid to liquid if heat transfer is taking place. As you can see, this one is the solid body, this can is the solid body, and this one is the liquid or vapor. From here heat transfer is taking place. So this type of convection, this type of transfer, it is known as the convection. This type of heat transfer, it is known as the convection. This type of heat transfer, it is known as the convection. Solid to liquid, solid to liquid. So, this type of heat transfer action, it is known as the convection. As you can see here, this type, other than, see here conduction will be there, here convection will be there, and other than that, that one is, this one come under the radiation, this one will come under the radiation, and this one will come under the radiation. Other than conduction and convection, if heat transfer is taking place, here also heat transferring is taking place. So, that type of is known as the radiation. This is the conduction, that one is the convection, and this one is the radiation. You have to remember what is conduction, what is convection, and what is radiation. If solid to solid heat transfer is taking place, that one is known as the conduction. If solid to liquid or liquid to liquid heat transfer is taking place, that one is known as the convection. If solid to liquid, if solid, other than conduction and convection, if heat transfer is taking place, that one is come under the radiation. Other than conduction and convection, if heat transfer is taking place, that one come under the radiation. You have to remember this, what is conduction, what is convection, and what is radiation. This area it is known as the conduction, this area it is known as the convection, and this area it come under the radiation. You have to remember conduction, convection, and radiation. These three are come under the modes of heat transfer. These three are come under the modes of heat transfer. Next one is the Fourier's law of heat conduction. This is the important law of heat conduction. You have to remember, in short or in long bit will become. So, what is the Fourier's law of heat conduction? You have to remember this one. What is that? Fourier's law of heat conduction. Fourier's law of heat conduction. What is the Fourier's law of heat conduction? You have to remember this one. Fourier's law. Suppose if you consider a simple homogeneous solid section, if you consider a simple homogeneous solid section like this, somewhat simple homogeneous solid section is there. This one is the simple homogeneous solid section is there. This one is what is there? Simple homogeneous solid section. As you can see, simple homogeneous solid. The rate of heat transfer, the rate of heat transfer is designated with the letter. The rate of heat transfer is designated with the letter rate of heat transfer. This one is known as the heat transfer. The Q is stand for the heat transfer, and small q is stand for the rate of heat transfer. You have to remember this. Capital Q stand for the heat transfer, and small q stand for the rate of heat transfer. You have to remember this. Capital Q stand for the heat transfer, and small q stand for the rate of heat transfer. So, here two things are there. First one is the heat transfer, and second one is the rate of heat transfer. These two things are there. So, the rate of heat transfer, the rate of heat transfer through a simple homogeneous solid. This one is the simple homogeneous solid is there. Okay, na solid, simple solid body is there. This is not hollow, inside field is there. So, the rate of heat transfer. So, here the rate of heat transfer, how much heat transfer is there? The rate of heat transfer. The rate of heat transfer through a simple homogeneous is directly proportional to its cross sectional area. How much area is there? How much area is there? The rate of heat transfer through a simple homogeneous solid. The rate of heat transfer, the rate of heat transfer through a simple homogeneous solid is directly proportional to its area, is directly proportional to Q is here. As you can see, Q is directly proportional to its area. Q is directly proportional to its area. Q is directly proportional to its area, and its difference in temperature gradient, and difference in temperature gradient, and difference in temperature gradient, and inversely proportional to its length, and inversely proportional to its length, and inversely proportional to its length. Sometime we will call as a dl, sometime we call as a dx, or sometime we call as a x. Different author will follow the different indication for some. Dx, dl, thickness, length, you can consider whatever you want. Dl will be there, some in the Rajput or some readers dl will be there, in Sharmas or other readers dx will be there, or some authors will follow the x. It's up to you, whatever the indication you want, you can take that one. So, dl will be there, dx will be there, and x will be there. Dl will be there, dx will be there, and x will be there. You have to remember. So, the simple homogeneous, the rate of heat transfer, what is that? The rate of heat transfer through a simple homogeneous solid, the rate of heat transfer through a simple homogeneous solid is directly proportional to its area. and the gradients means difference in the temperature, gradients mean difference in the temperature, and it is inversely proportional to its path or length, is inversely proportional to its path and length. So, you can say that q is directly proportional to a dt by dx, q is directly proportional to a dt by d, half of the, see most of the problem you can do with the help of this formula only, Fourier's law of heat convection, Fourier's law of heat convection, q is directly proportional to a dt by dx, q is directly proportional to a dt by dx, you have to remember this one, q is directly proportional to a dt by dx, where q stand for heat transfer, q stand for heat transfer. So, I will write here heat transfer, q stand for the heat transfer, the unit is watt, q stand for the heat transfer, the unit is equal to how much is there, watt. Next one is the dt, dt stand for gradient of temperature, 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 and dl stand for thickness, dl is stand for thickness, dl is stand for thickness. You have to remember that q is equal to heat transfer, dt stand for a gradient of temperature, dt stand for gradient of temperature, and dl is stand for thickness, and small q is also there. Small q is known as rate of heat transfer. You have to remember rate of heat transfer, unit is watt per meter square, because small q, if you see, small q is equal to capital Q by area, small q, if you want to take, small q is equal to capital Q by area. So, here you can write W by meter square, what you can write here, W by meter square, here you can write W by meter square, W stand for watt, W stand for watt. So, you have to remember this one, what is Fourier law of heat convection, what is Fourier law of heat convection, here simple definition is there, Fourier law of heat convection, the rate of heat transfer, through a simple homogeneous solid, the rate of heat transfer through a simple homogeneous solid, is directly proportional to its area, and directly proportional to its temperature, and inversely proportional to its path, means length, path. You have to remember this one is known as the Fourier law of heat conduction, Another thing, q stand for heat transfer, unit is watt, and dt stand for gradient of temperature, stand for gradient of temperature, and dl stand for thickness, and q stand for rate of heat transfer, unit is watt per meter square, and you have to remember sometime dx, dl or x, dx or L, both are thickness only, or you can say as a length also, and small q can be write as a small q is equal to capital Q by A, where capital Q is equal to watt and small a is equal to meter, small a is equal to area unit is length into breadth, meter into meter square. So, capital Q unit is watt per meter square, capital Q unit is watt per meter square, and so small q unit is watt per meter square, capital Q unit is watt. You have to remember that small q unit is watt, the unit is important because all in this all similar units will be there. So, you have to remember that. What is Fourier law of thermodynamics, Fourier law of heat transfer, the rate of heat transfer, through a simple homogeneous solid, is directly proportional to area, and difference in the temperature gradient, and inversely proportional to its length, You have to remember this. This one is known as the Fourier law of heat conduction, Next, after that, in that only you have to define that one. How you have to define that one? How the Fourier law of heat conduction will be there? You have to derive that one. Without derivation, that one You will not get that. Derive means you have to explain that one. What are the things are there and what you have to tell about that one. So, here I will write that. Once again I will tell you that Fourier law of heat conduction. What I have to tell? Fourier law of heat conduction. So, here as I told you, Q is directly proportional to A dt by dx. This one is known as the Fourier law of heat conduction. Q is directly proportional to A dt by dx. Q is directly proportional to A dt by dx. This is the Fourier law of heat conduction. Now, what I am doing? I am removing the proportional sign. What I am doing? I am removing the proportional sign. So, here as you can see, if I remove the proportional sign, in place of that minus k I have to add. What I have to add? Minus k. K is the constant, coefficient of constant. Here k is the constant is there. Why I am adding here minus sign? Why I am adding here minus sign? What is the reason that I am adding here minus sign? Because heat is losing, heat is not gaining. In any solid body, if heat is going, so heat is losing, it is not gaining, heat is automatically decrease, automatically. If heat transfer means increase will be not there, more 99% it will be decrease. Heat transferring, heat gain means automatically heat will come, but heat transfer means automatically heat will be lose. So, here you can write minus. So, here what I am doing, Q is equal to minus K A, here I am writing dt by dx. What I am writing? Q is equal to minus K A dt by dx. Q is equal to minus K A dt by dx. Q is equal to minus K A dt by dx. What I done here? See, in place of this proportional sign, I remove that, and in place of that I introduce these three words. In place of proportional sign I remove that. In place of that I introduce what I introduce? Minus K A. What I introduce here? Minus K A. After that what you have to do? Q write down as it is equal to minus K A, write down as it is. Here you can write T1 minus T2. Here you can write T1 minus T2. I told you this one you can write as a dl or dx or x. It's up to you, your wish. dl also you can write, dx also you can write, or x you have to write. So, better to write dx, better to write dx here, okay na, better to write here dx. So, q is equal to minus k a t1 minus t2, q is equal to minus k a t1 minus t2, tu is equal to q is equal to minus k a t1 minus T2. This is the Q is equal to minus K A T1 minus T2, rate of heat transfer. So, here Q is equal to minus K A T2 minus T1. What is there? Q is equal to minus K A T2 minus T1 by dx. dx can be write as a L also. So, after that what I am doing? Q is equal to minus K, see here minus K A, minus I am shifting in this side. So, here this one is the positive term. Which term it is? Positive term. Positive term will become negative, and this one is the negative term. Negative term will become positive. Vice versa will be there. You have to remember this one. Vice versa will be there. See, this is the T2 is the positive. Here if you multiply with minus, this one will become negative, and T1 is the negative. If you multiply, this one will become positive. Negative will become positive, positive will become negative. After that what you have to do? Q is equal to K A T1 minus T2 by L is there. After that you have what you have to do? A you have to bring this side. So, Q by A is equal to K, write down as it is T1 minus T2 by L, write down as it is Q by A K T1 minus T2 by L, Q by A K T1 minus T2 by L. What I done here? Just A I shifted this side. See, Q by A can be write as a Q, small q, rate of heat transfer. Small q is stand for rate of heat transfer. So, small q is equal to K I am writing as it is. Here I am writing T1 minus T2 by L I am writing as it is. After that small q is equal to T1 minus T2 by, here I am writing L by K. Here I am writing what I am writing here? L by K. then small q is equal to T1 minus T2 by, in place of that you can write RTH. RTH is known as the thermal resistant. RTH is known as the thermal resistant. In place of L by K you can write as the RTH. In place of L by K you can write as the RTH. So, small q, the unit of small q is equal to watt per meter square. The unit of small q is equal to, what is the unit of small q? Watt per meter square. You have to remember this one, watt per meter square.